This video will cover how to use the Perievent function in Danse. Specifically, we will first define Perievents, cover the required prerequisites, then demonstrate how to use the function, before finally ending on how to save and export figures and data. Use the following timestamps to skip to the relevant sections. Perievent histograms are one of the most common ways to quantify how neural activity changes in response to a time-dependent stimulus or behavior, which we will refer more generally as events. Perievent histograms are created by selecting the neural activity around repeated iterations of the same event, aligning them and averaging them together. Thus, there are two prerequisites before we can analyze data with the Perievent function. The first is continuous neural or behavior data, such as delta f over f, speed, or any other measure. The second is event type data, which can either be repeated single time points or many larger time windows. If you do not have any event type signals, check out this video for a detailed tutorial explanation. To create a Perievent histogram, select the Analysis tool. This opens a window where we can select the type of analysis that we want to do, in this case, Perievents. Here, we must specify the path to the continuous data within the file manager. Start with the data folder, then specify the driver when necessary, the group, the series number, and finish with the dataset before selecting Apply. Next, a second window appears where we will define both parameters for the Perievent, but also for the calculation of the Perievent-related statistics. Let's start by picking the event of interest from the Events folder in the file manager. Note that all three types of events, only onset, only offset, and onset and offset, are compatible with this analysis operation. Next, the onset-offset parameter specifies what portion of the event will be used to align the neural data. For single-type events, the onset-offset parameter is always only onset. However, for onset and offset type events, like event 3, the only onset option aligns the data based on the start of the event, the only offset aligns the data based on the termination of the event, and the onset and offset creates two sets of plots, one for its starts and one for its termination. The Perievent timeframe refers to the window around the event, which is always the reference at 0 seconds. The first value specifies how many seconds before the event will be included in the plot and should always be negative, while the second value specifies how many seconds after the event will be included and should always be positive. The last parameter related to the Perievent plot is the normalization. This parameter is useful when there's a lot of variation in the baseline of each aligned neural trace, which can hide real effects, especially when the baseline of one trace is near the peak value of another. By enabling the normalization parameter and specifying the baseline window, we will subtract the average baseline from its corresponding neural trace, setting all the baselines near 0. If we compare before and after normalization, we can see that the difference between a baseline and the peak is much larger when normalization is enabled. Next, select what Perievent statistic we would like to calculate between the area under the curve, the mean, the median, maximum, or minimum values. The chosen statistics will be calculated for each specified time frame. For example, here we can compare the area under the curve during the baseline window of -1 to 0 seconds, and after the event in a window between 1 to 2 seconds. To add additional timeframes, use the plus button, or remove a timeframe with the minus button. Finally, we can create our plots by selecting Apply. Here we can see the two plots we created, Perievents and the related statistics. These plots are saved under the Data Analyze folder. By right-clicking on the graph, we can change several parameters, including how the signal is displayed, either as individual traces, with a standard deviation, a standard error, or 95% confidence interval. We can also change the width of the event like so, or update the color of the plot. Finally, you can overlay a second signal in the same graph to compare the shape of two different traces. The statistics graph can also be updated. We can change the type of plot displayed between multiple lines, scatter plot, box plot, or bar plot. We can also superimpose these options together, or update the type of error used in the plot, just like Perievents. To export the figures, select the Save Plot icon. This opens a window where you can adjust the dimension of the plot, text-related parameters, and select the export format between PDF, JPEG, and PNG. Alternatively, using Doric file editor and loading a Doric file, we can export the actual data as a CSV file, or copy and paste signals of interest. To recap, using continuous data and event time points, we created peri-event histograms and calculated their related statistics, both of which can be saved as figures or exported in Doric file editor. If you have any additional questions or concerns, please contact us at support@doriclenses.com.